Welcome to this video on setting up a secure malware analysis lab. Analyzing malware in an uncontrolled environment can lead to catastrophic consequences, including data loss, system compromise, or network infections. One small mistake can lead to a total compromise of your system. That is why we must follow secure handling procedures, always double check the configurations, and avoid careless mistakes. Let us now move to setting up safe virtual lab using virtual machines. After all, malware analysis is a crucial skill in cybersecurity, but performing it directly on the main system can be extremely risky. In this video, we will explore how virtual machines or VMs can provide a safe control environment for malware analysis. A virtual machine is a software-based simulation of a physical computer. It runs on a hypervisor, which is responsible for creating and managing multiple VMs on a single physical machine. This setup enables security researcher to analyze malware without compromising the primary system. Here is how a typical virtualized environment is structured. At the base, we have the hardware, which includes the physical components like processor, memory, and the storage. Above that sits the host operating system, which is the main operating system running on the physical machine. In our case, it will be Windows 11. The hypervisor sits on top of the operating system, which is responsible for managing the VMs. It provides all the services needed by the virtual machines by interacting with the kernel of the host operating system. Finally, we have guest operating systems. These guest operating systems can be Windows, Ubuntu, or any desired operating system required for the use case. One of the biggest advantages of using VMs for malware analysis is the isolation. Malware executed inside the VM remains contained within that environment that does not spread to the host operating system. This significantly reduces the risk of accidental infections. Another powerful tool for which we will use VM is snapshot and rollback. Snapshot captures the current state of the VM, including all the files and settings. If malware modifies the system file or behaves unpredictably, you can quickly revert to the clean state with just few clicks. This saves times and ensures a consistent testing environment. A control environment allows the analyst to execute and monitor malware safely. By setting up various network monitoring tools available in the virtual machines, debuggers and system analyzers, researchers can observe how malware infects the system and the network. This is essential for understanding how threats operate and how to mitigate them. Virtualization has been made possible by Hypervisor, which manages and allocates the system resources to each VM. Here, there are two types of hypervisor: bare metal hypervisors and hosted hypervisors. Discussion on this is beyond the scope and requirement of this course. On the slide, we can see that there are various advantages of using virtual machines over physical machine for malware analysis. As mentioned, it provides isolations, easy reset options after we detonate the malware. Although performance overhead is slightly more in virtual machines, but that nullifies with the advantages it gives. Virtual machines can support multiple operating systems, unlike the physical machines. Overall, the cost and convenience of using virtual machines is way lower than physical machines. For using hypervisor, we have three options: VirtualBox, VMware, and Hypervisor. For our course, we will use VirtualBox because it is open source, it has a great community supports, and most important, it is very easy and convenient to use. Now let us dive in setting up our first malware analysis lab. So here I am on my base operating system, which is Windows 11. What we are going to do, we are going to install a Windows 10 evaluation version on a VirtualBox for our malware analysis lab setup. For this, we will first go and find Windows 10 ISO from Microsoft Evaluation website. As always, we will open Google from our Edge browser. Then we will open Windows 10 Evaluation ISO. After searching this, you will get the first link for Windows 10 Evaluation Center. We will click this. From here, we will download Windows 10 ISO Enterprise. Here, a page will pop up. As obviously, we will set up dummy data here. I work for XYZ company. I live in Cameroon. I work in a very big company. My job role is Kane XYZ. My country code is Cameroon and my phone number is something like this. Yes, I accept. Oh, email should be proper. I will just correct my email. Then I will go to download now. From there, you will be directed to the Windows 10 Enterprise download page. Here there are various language options from which we will select English United States 64-bit version of Windows. Now here you can see our downloads had started and it is showing approximately 50 minutes. So let's grab a coffee or a snack and I will be back after that. So finally we have downloaded our Windows 10 ISO from Windows Evaluation Center. You can see here the size of the file is around 5.2 GB. Now we will move to our next step of downloading Hypervisor VirtualBox in our base operating system. For that we will go to Google again and search for download VirtualBox for Windows. From here we can download the Windows installer file. VirtualBox is an open source hypervisor which is maintained by Oracle. It is very convenient to use as it provides all the features of a commercial hypervisor tool. We will just wait for it to get downloaded. Now, since we have downloaded the VirtualBox installer, go and install it. On the USC, click yes. Select next, accept the terms and license. Select yes. Click next and install. Click finish. And here we are. We have successfully installed VirtualBox on Windows 11 base operating system. Now our next step is to make that Windows 10 VM for which the ISO we have just downloaded. For that we will make a new VM. We will name it Windows 10. In hardware, we will select the RAM which we want to dedicate to that VM, the number of processors. Please keep this in the green thing, otherwise it will create issues in the base operating system due to overload. From here we will choose the hard disk which we want to allocate for our VM. I will dedicate 100 GBs and then click finish. So we have done all the basic settings. Now we are ready to boot up our new VM. I hope you all have been following along till here. Now we will boot up our new virtual machine which we have made. For that, in the above toolbar you will see a start button. Go and click on this. Oh, we ran into an error. Our first job will be try to figure out and troubleshoot this error. So welcome back. As you saw that we ran into a trouble. An error occurred when we start to boot up this VM. These kind of errors will keep occurring when you will do or learn something new. The attitude should be always to solve these errors. There are many online communities and help available which will give you the solutions. So the issue here was that we need to start our VirtualBox as an administrator, because of which some kernel files were not loading up. Here we will start our VirtualBox as an administrator and then start this VM again. This time our VM has been successfully loaded. Now in this step we will now choose the ISO which we downloaded. Remember, right now we have not given any ISO file to this. We will go to our downloads and select the Windows Evolution ISO file which we just downloaded and mount it. You will see there that our Windows has been loaded up and the installation process for Windows has started. Now we have to just follow the basic installation steps for installing our Windows 10 VM. Accept the terms and license. Here we will select the 100 GB of the virtual hard disk space which we have allocated for this VM. This will take some time and I will pause the video and I will be back when. So we will do some final touch up in our Windows installation. Select next. Select the language. Skip layout for now. You will be prompted for a Microsoft account. Don't worry, there is a way to bypass it. At the bottom you will see an option, join domain instead. Here you can write your name and then you can choose a password, re-enter the password Select the security question. And click next. Don't set up Cortana for me. Windows is doing final touch-ups in the installation. So we have finally installed Windows. Congratulations everyone. Here you might be seeing that the screen is only this small one. Don't worry, you don't have to do this entire malware analysis course on that small screen. There is a way to increase its size. Here in the above tab you will see devices options. In this you will see insert guest editions CD image. Click on this. When you will go to this PC, you will notice that a CD has been inserted here, which is for virtual guest editions. Basically, virtual guest editions are the collection of all the tools which enables us to use the VirtualBox in a very hassle-free manner. It provides all the drivers and the mouse and file sharing options which we can use for our virtual machine. From when you open the CD, you will see a number of options depending upon the operating system that you have. We will go and choose VXBox Windows Edition AMD 64 as we are running a 64-bit Windows 10 machine. Go and click next and install this. Now there is a prompt that whether you want to reboot it now or reboot it later. We will select reboot now. So when rebooted, enter your password again. Go to this option for view full screen mode and click switch. And here we are. We have successfully installed VirtualBox on a full mode, full screen. CMD command prompt will pop up, but don't worry. You can see that Windows 10 has been successfully loaded. Since we have downloaded our first Windows 10 virtual machine on Oracle Box and it is successfully running, we have also sorted the issue of full screen resolution on it. I will love to give a quick walkthrough of the VirtualBox. Since we will be using this tool for entire course, it is very crucial that you know how to operate and run this course. Over the above tab, you will see a file option here from where you can import a OVA version virtual machine directly. You can export a virtual machine from here. Then on this tab where I'm pointing, you can create a new virtual machine. On the settings tab, you will see all the settings related to the virtual machine. You will see the general setting which are related to the name and other details. Then there are system settings. Actually right now the virtual machines is running, that is why most of the options are not available. First let us close this virtual machine. For that you will go here and go and power off this virtual machine. Now come back to the setting. Now you can see you can change the name of the virtual machine from here. You can also change the amount of memory RAM allocated. You can see the processors from here. Here there is acceleration option. Actually we will select Hyper-V from here because Windows supports Hyper-V resolution. From here you can see that Windows 10 VDI is 100 GB space which we have allocated. Then there is networking mode. This is a very important topic and I want to discuss these networking modes in detail. You can see that there are various type of networking modes which are being shown here. Let us discuss them in brief with some examples. So we are diving into an essential topic for everyone who is working with virtual machines, that are networking modes in hypervisor. Whether you are setting a lab for cybersecurity, testing malware security, or just experimenting with virtualization, understanding how the VMs communicate with each other is very essential. I will break down different networking modes and how they work and when to use them. First of the mode is NAT mode, Network Address Translation mode. This is a default setting in most of the virtualization platforms like VirtualBox, VMware and Hypervisor. It allows the virtual machine to access the internet while keeping it isolated from the other machines on the network. Let us break down how it works and when to use it. For this, we will take an example of a dummy lab setup. In this lab setup, you can see that the internet is provided to the physical router, and in turn that physical router provides internet to our physical PC and our physical host over which our hypervisor is hosted. Here, physical host is the machine over which the VirtualBox is running, and we have made two VMs, VM1 and VM2. You can also see the IP allocated to the physical host and physical PC. It is in the range of 192.168.254 and 101 and 102. Whereas the IP address which is allocated to VM1 and VM2 is translated by the VirtualBox which is present over here. This means that these two are not in the same IP range. Although there is always a one-way communication which is available from VM to physical host, through which the VM can access the internet, but vice versa is not possible. So this natting mode is commonly used for safe browsing inside a VM without exposing it to external threats, running internet connected application in an isolated environment, testing malware samples securely without spreading them to other machines. Although running this for malware lab is not recommended, but if you need to give internet for testing some samples, then this mode can be used. However, NAT has some limitations also. VMs using NAT mode cannot communicate with each other because VMs get their own private IP behind the host. Here, our host, physical host, which is 192.168.254.101, over which VirtualBox is running, they provide IP address to these VMs, and there is no communication possible between these two VMs in NAT mode. These VMs are isolated with each other in this mode. Subsequently, it is not ideal for running web servers and other services which need networked testing, because for that, if I am running a server in my network, I would need that the server is accessible from all the machines on the network. But here this is not possible, since the IP address of this VM has been translated by the physical host, and for the outside world it remains hidden. So VM gets the IP address from virtual DHCP server, No communication between the VMs is possible. Second comes the bridging network mode. Unlike net mode, which isolates the VM, bridge networking modes connect the VM directly to the physical network. This allows the VM to act like a normal device on the network, just like a physical computer. We can see this again by taking example of this lab. Here, instead of using NAT mode, we have used bridge mode. In the NAT mode, if you remember that the VM1 and VM2 get the IP address by the virtual DHCP server running on this physical host. Here, the physical router of the network itself provides the IP address to these two VMs. These two VMs can communicate freely among each other and all the other machines on the same network. For example, this VM1 can directly communicate this physical PC because they are in the same network range. Internet is also available on these VMs. This makes bridged mode an ideal for network testing, running servers in situations where VM needs to be treated as a real machine on the network. However, bridged mode has some risk also. Here, the VM is fully exposed to the network, meaning it is vulnerable to attacks. Malicious software inside the bridged VM can spread to the host and other network devices. It may require additional configurations in corporate network where DHCP is limited. Here, our physical router, the DHCP present in the physical router is providing the IP address to this VM1 and VM2. In some cases, due to limitations, this can be a hurdle. So, internet is available to all the VMs, communications between the VM is possible, and VM get their IP address from the router subnet. Our third mode is host-only network mode. Host-only network mode is an isolated networking mode that allows communication between the VM and the host, as well as between the VMs, but completely blocks the internet and physical network access. It is ideal for secure private lab setup. Here we will see another example that in the same setup, our Oracle VirtualBox is running on the physical host and we have created two VMs, VM1 and VM2. You can see here that the IP address allocated to physical host is different from the IP address of the network. Here VM1 and VM2 are also provided the IP address range by this physical host, and it is also different from our rest of the network. There is no communication possible to the outside world. Only these three VMs can communicate with each other. No internet access is available to the VMs. Communications between the VM and the host is possible, and among the VMs also it is possible. These VMs get their IP address from the virtual router present over the physical host. Now there is a brief comparison of various different modes. You can pause the video and see this. I have already explained everything. I will talk about one another mode, which is internal mode. In internal mode, access to all the VMs is allowed and rest everything is restricted. This is used for testing extremely isolated environments where there should be no network communications at all from the outside world. And there is one another mode, which is NAT network mode. Remember, I told you in NAT mode, the access to other VMs by the VM was not possible. In NAT mode, the VMs can communicate to the other VMs located on the same host. So this was it about the networking modes in the hypervisor. It is very essential to choose the correct networking mode for the correct use case. We are back to our VirtualBox explanation video. I have briefly explained you all the networking modes present over here. Then one important is share folder. Here you can share any folder to exchange files from your host system to your virtual machines. From here you can select a folder, and for example you can make a new folder here, sharing folder. Now this folder is mapped to the virtual machine, and all the communications and all the file sharing can happen over the shared folder. Now we will move ahead and install FLARE VM on our Windows VM, which is a very important tool used for malware analysis. FLARE is a Windows-based malware analysis and reverse engineering virtual machine environment. It is an open source and automated lab setup developed by FLARE. It is a team of Mandiant. Basically, it is a collection of all the tools which are very essential for malware analysis. It is an open source script which download these open source tools from the internet and gives us the collection at one place. There are various static analysis tools like P Studio, Detected Easy, dynamic malware analysis tools, reverse engineering tools, forensic and network monitoring tools, etc., which are available. So it uses chocolatey Windows package manager to download all the tools, regularly updated by the cybersecurity community. It has these two tools are pre-configured for analysis so that you don't have to do anything. So let us boot up our VM again and install FLARE. We are back and loaded our Windows VM and we are ready for FLARE installation. For FLARE installation, we will open our browser and open Google. On Google, we can go and search FLARE VM GitHub repo. So this will give us the official FLARE VM GitHub repo. You can see that in the description, FLARE is a collection of software installation scripts of Windows systems that allows you to easily maintain the reverse engineering environment. We will go down and see the requirements. We should have Windows 10 and above. It is there. We should have PowerShell. Disk capacity should be at least 60 GB and memory of at least 2 GB. We already have that. Username should not have any spaces. Our username is John, so there is not an issue. Internet connection should be there. Windows Defender should be disabled and Windows Update should be disabled. So we will do this when we will install. First, see here, we need to get one installation script known as installer.p1. For that, we can wget it, or there is one other option that we can download the entire repository to our virtual machine system. Here we have downloaded the zip folder. We can go in downloads and extract it here. Here you can see all the things which are required for the installation are there. Now we will do some of the things as recommended in the installation that we will first we will shut off our Windows Defender. Here go to threat protection and there will be a UAC. We will do one more change, that we will go and we will shut down our Windows Defender firewall. Here from this left, choose turn on and off Windows Defender Firewall. OK. Now we have taken care of all the things which needed to be turned off before installing FLARE. We will open our PowerShell as administrator. This is opened as a normal user. I need to open PowerShell as administrator. On the right pane you can see run as administrator. Here we will go into the directory where our FLARE is installed. We will cd into it, and here we can see that all the files are there. After that, we need to do some more things. We need to first unblock this PowerShell file. So we will go in the GitHub repository and copy the command unblock file, install ps1. Our next step is to set execution policy to unrestricted. We will copy this as well and run this. Our final step is to run the install ps1 script. We'll do some check-in and verifications like username, space, Windows version, and then it will ask for prompt. Say yes, enter your password here. So you can see after some checks our FLARE VM installation has started. This will take some time, so I will just pause the video and I will be back when this is done. Thank you so much. So finally, after a long wait, our FLARE VM has been installed. You can see here in the tool sections on the desktop, all the tools required for our analysis have been installed here. We will use these tools during our Malware Analysis Lab practice, where we will detonate the malwares and see for various malicious artifacts using these tools. Now we will go and install another VM which was required for our setup, which is REMnux. Hello everyone, welcome back to the channel. We have already installed a Windows virtual machine on Oracle VirtualBox. We have already installed a FLARE VM on it, which is a collection of open source tool which we will use in our Malware Analysis Labs. Now we will be installing another VM which is known as REMnux. It is a most powerful Linux based distro designed for reverse engineering and malware analysis. Whether you are a cybersecurity student, analyst, or malware researcher, REMnux is a must-have in your virtual lab. Now we will be going and installing REMnux OVA in our VirtualBox. To install REMnux, we will be going to its official website. REMnux is a free Linux toolkit developed by Lenny Zenster and is maintained by REMnux team. It is built on Ubuntu and comes with preloaded tools for static analysis, dynamic analysis, reverse engineering, and network forensics. It has tools like Radar2, Cutter, Ghidra, Flaws, Virus Total Lookup, and many more. Alright, now let's go and download REMnux. There are both options of installing REMnux. Either we can directly download its VirtualBox OVA file, which we can directly import in our VirtualBox, or we can also install it over Ubuntu and do a individual installation. To download the OVA of VirtualBox, we will go here and click on this link. Download the file from here. As you can see, the OVA file has started downloading. I will pause the video and return when it will. Using REMnux is very easy. It comes with a very comprehensive documentation, as you can see on the screen. There are instructions to download the virtual appliance. REMnux virtual appliance is approximately of 5 GBs. It has also the steps how to install it over Ubuntu VM. Then there are details about various tools which are available over REMnux. As you can see, all the list of tools are mentioned here, like Detected Easy, Exif tool. Also, the documentation page of these tools are also mentioned. We will go over these tools during our course. So now we have downloaded the REMnux OVA. Now we will go and install it in the VirtualBox. We have already our Windows virtual machine running on Oracle VirtualBox. We will make one another REMnux VM. For that, click on the File option and select Import Appliance. Now choose the location of the OVA file which we have just downloaded. Click Open. We don't want to do any change in the configurations and click Finish. VirtualBox will import the OVA file. So our REMnux VM has been successfully imported on Oracle VirtualBox. You can see the details of this on the screen. If you want to change anything, you can change here from the Settings tab. You can change the storage, display, memory and all other settings as required. Now we will go and boot up the VM by clicking on the Start button on the toolbar. So our REMnux VM has been booted up. First of all, we will go on and update the installed packages over the VM. For that, we will go and type sudo get update. After updating, we will go and run and upgrade all these updated applications. For that, we will again go in the command prompt and type sudo apt upgrade. Click yes on the prompt. Until our apps are being upgraded, I will give you a brief overview of our REMnux VM. When you click on the activities, a site tab will open up. On this, if you open, various applications installed on REMnux VM will be visible. You can go here and search for any application required. REMnux is a VM which is a collection of number of tools which are required for malware analysis. So now our apps have been upgraded and updated. Now what we will do, we will close the REMnux VM and do some configurational changes in our VM. Till now we have installed Windows VM and a REMnux VM. Now we will do some configurational changes for network setup of our malware lab. Our malware lab will eventually look like this. On the left, you can see that we have a physical PC, which is actual host machine. Its IP address is allocated by our router. That's your primary system outside the malware lab. Now, there is another VirtualBox which is hosted on this physical PC. Over this VirtualBox, we have made two VMs. One is FLARE VM and other is REMnux VM. Inside the red dotted circle, we have a host-only virtual network, a secure and isolated space created using VirtualBox or similar virtualization software. This ensures that the malware cannot leak in the real network. At the center of the red dotted circle, VirtualBox host adapter, which has the IP address of 10.0.0.1. Over this, we will also run a DHCP server with IP address of 10.0.0.2, which will provide the IP address to these other two VMs. The REMnux VM is running in the same series as 10.10.0.4. and our FLARE VM is running at 10.0.0.3. Now, in our setup, we will do actual malware detonation on the FLARE VM, and we will use REMnux VM as a proxy to analyze the network-based indicators arising out of the malware detonation in this FLARE VM. We will use FLARE VM to see host-based indicators. This is where the malware sample will be executed in the control environment. We will be monitoring host-based indicators such as file changes, registry edits, process injections, and more. Whereas on the REMnux VM, we will observe network-based indicators like the DNS request, command and control traffic, and many more. To do this setup, we have to create a separate network adapter, which will facilitate this configuration. Now let's go back to our lab and set up a network adapter. To set up a new network adapter, we will go to our VirtualBox manager. Here in the Tools section, when you will right click, you will see an option for various tools options. Here on the third number, you can see there is an option for Network Manager. Click on this. Here there is an option to manage all the Ethernet adapters. Here we will create a new Ethernet adapter for our host only lab setup. Here you can see that adapter has already given it an IP address. We will change it to our new IP address, which is 10.0.0.1. Now we will make the changes in DHCP adapter as well. Click this option of enable server and here allocate a new IP to our DHCP server, which is 10.0.0.2. The server mask will remain the same. Now we will have to enter the range in which the new DHCP server will allocate the IP ranges to our VMs. Here put lower bound IP address as 10.0.0.3 and upper bound address at 0.0.0.4. Click on apply. Now we will go back to our REMnux VM settings. Here we will open networking options. You can see by default the VM is running on NAT mode. We will change this to host only adapter, and you can see that new adapter, there are two adapters which are showing. We have to carefully choose the adapter which we have currently made for our host only setup. After selecting this, click OK. Now we will go and change the network adapter for our Windows VM also. For this, go to Windows 10 VM and open settings, and here also change the adapter to host only adapter, and again change the second adapter which we have dedicatedly made for our lab. Click OK. Now boot up both the VMs. Now on your REMnux VM, go and see what IP address has been allocated to it. For that, go in the terminal and type IPA. You can see REMnux has been allocated an IP address in our local range, which is 10.0.3. We will go and check the same for our Windows VM. On the Windows VM, open command prompt to see what IP address has been allocated to it. Type ipconfig. You can see our Windows VM has also been allocated the IP address in our local range, which is 10.0.0.4. Now we will try to ping our REMnux VM for our Windows VM. Remember, the IP allocated to our REMnux VM was 10.0.0.3. You can see here we are successfully able to ping our REMnux VM from our Windows VM. We will go and do the same from our REMnux VM. Ping on Windows VM. So now it has been established that our setup is in a perfectly host only network where the two VMs are able to communicate with each other. Now let us once check for internet connectivity also. For that, we will go and ping to Google IP. You can see the network is unreachable. Hence, it is confirmed that no network is available, no internet is available for our VMs, and our VMs are safe to analyze the malwares. Here we will do one another step. We will take the snapshot of the current state of our REMnux VM. We will name it all setup. In description we will write the IP which has been allocated to it and click OK. This will go and take the snapshot of the current state. This is the current state of our VM. We will go and do the same for our Windows VM as well. We will go and take the snapshot for this. Remember, this is a very important stage because we will be again coming back to this state after we deploy or detonate our malwares. So it is very important to maintain snapshot to which we can retract. So as you can see that our snapshot has been made for both the VMs. One another tool available in REMnux is inetsim. Inetsim mimics the behavior of the internet services so that the malware thinks it is communicating with the real internet, when in fact it is contained within a safe isolated web. So it simulates the internet services such as HTTPS, DNS, etc. and logs all the requests which are coming from the Windows VM. To start inetsim on my REMnux VM, I will type inetsim and press enter. As you can see, the inetsim has been successfully started on my REMnux VM. It has started a number of services as shown on the screen. Now I will go on my Windows VM and open the IP of my REMnux VM, which is 10.0.0.3. As soon as I open the IP, you can see a fake page from iNetSim has been displayed. Even if you open some URL like abc.exe, then iNetSim provides a fake executable file. This is the general behavior of some malwares, that they download external payloads using some IP address or URLs. So whenever we receive some request like this, iNetSim provides us with a fake executable file, just as to mimic the behavior of an actual malware. One another feature of iNetSim is providing fake DNS. To start fake DNS service on our REMnux VM, we have to do some configuration changes in the iNetSim configuration. To do that, go on REMnux VM and type sudo nano etc inetsim inetsim.conf file. Here, the first change that you have to do is you have to remove the comment in front of start service DNS. When you will remove the comment, the text will appear in the white. Now go down and change the service bind address to the IP address which has been assigned to your REMnux VM. In my case, it is 10.0.0.3. You can do IPA to check what is the IP address assigned to your REMnux VM. After that, go down. Now change this DNS bind port to 53. Remove the comment in front of it. And the next change which you have to do is change the default DNS IP address which is returned in the response address. Change this to 10.0.0.3. You can change this to anything as per your wish, but in my case I have kept it 10.0.0.3 for simplicity. Now save this file. After this, restart your iNetSim service. For that, type sudo systemctl restart iNetSim. Now your iNetSim has restarted. On the Windows VM, you have to make just one change. You have to go to the network adapter and change the default DNS address. Here, open the network settings, open Ethernet and change adapter options. Here, you will open Ethernet network adapter and its properties. In that, you will find the option of IPv4. Here, go and change your default DNS to 10.0.0.3. Remember, don't change the default IP address, as our IP address is being assigned by the DHCP server which we have already configured on our VirtualBox host on 10.0.0.2 IP address. Press OK. Now go to Windows virtual machine and search any URL over it. You will see a fake DNS page is shown here. You can also verify this by another command. Open command prompt, type ns lookup google.com. Here you will see there is a default response of 10.0.z from our iNetSim server. This is how you can configure a fake DNS server on iNetSim and REMnux VM in our isolated lab. I hope you have reached till here and successfully set up a secure malware analysis lab. To give you a brief overview, we have set up this malware analysis lab in which on the physical PC we have hosted a physical host VirtualBox over which we have installed two virtual machines. One is FLARE VM, which is running on IP address 10.0.0.4, and other is REMnux VM, which is running on IP address 10.0.0.3. As these IP addresses have been assigned by a DHCP server, this may vary in your case, but remember, they all will be in range from 10.0.0.3 to 10.0.0.254, as we have mentioned in our configurations. We are using FLARE VM for actual malware detonation, in which we will see host-based indicators like the registry changes made, process injections, and the file changes made by the malware. On the other hand, we have REMnux VM, which is a Linux-based distro, which will see all the network-based indicators such as DNS request, command and control traffic, and many more. Inside this red dotted mark, all these three will be lying in a host-only configuration where they will be able to communicate with each other, but there will be no outside communication to this lab. No internet will be available so that we can analyze our malwares in a safe security setup. It is very important to maintain and analyze the security setup because after all we are playing with actual malware here. Please double check your network configurations so that you remain secure.